Right. Yesterday, I introduced the idea of anti-differentiation, and we actually look at the family of solutions. You know that if there is a gradient function, which is differentiation, when you anti-differentiate it, you actually have a family of solutions because you don't know how the original function is translated along the y-axis. Alright? So, what we're looking at today, we are looking at particular solutions, which means you'll be given certain conditions. From that condition, you should be able to work out what the particular solution is, what is the original function. So for today, by the end of the lesson, you should be able to find the equation for an antiderivative given the initial conditions. And you should be able to apply antiderivations to solve problems involving functions, coordinates, critical points, and tangents. Alright? Mainly involving functions and coordinates first. Alright? Now, just recall from yesterday, when we reverse the process of differentiation, the anti-differentiation, at this stage, we learn how to use the power group. So if you know dy dx equals to ax to the power of n, y is therefore ax to the power of n plus 1, you increase the power by 1 and divide the whole term with the power, and then plus c. Plus c is important because we don't know where the graph is. Alright, the function is not the graph, the function. And just remember that at this stage, we can't use power function if n is minus 1. Alright? You will learn that next year, not now. Alright, here, I would like all of you to think about how you do this. This is a quick warm-up from yesterday. How do you find the antiderivative of the following function? You need to answer as radical where appropriate. Which means, if you have radical, you gave your answer as radical. So how would you go about doing this? You've got 3 terms, multiplied. What would you do? Thank you, expand it. So expanding it, so you know dy dx is therefore, let's start off with the first. Alright? There's x minus square root of x. Alright? 1 plus x squared. Alright? And therefore you know x minus square root of x plus x cubed minus x to the power of 5 over 2. Correct? Yeah? Is my expression correct? Yeah. So if that's the case, we can go y. Oh, actually, we can actually before that. Oops. What I want is rewrite everything. Write this as a power equals to x minus x to the power of half plus x cubed minus x to the power of 5 over 2. Makes life a little bit easier if you write it in power. So therefore y equals to x squared over 2 minus x. Half plus 1 is 3 over 2 divided by 3 over 2 plus x to the power of 4 divided by 4 minus x to the power of 7 over 2 over 7 over 2 plus c. Alright? Remember the plus c is important because there's a family of solutions. You don't know what c is. So therefore, that will be x squared divided by 2 plus 2 square root of x cubed over 3 plus x to the power of 4 divided by 4 plus 2 square root of x to the power of 7 divided by 7 plus c. So put everything in radical where appropriate. Alright? That's important. Happy with that? Yes. Now, let's move on. Thank you. So recall the family of solutions. You always put in the plus c. Alright? Because we don't know what the initial condition is. So the question is, what do we need to know to find the value of c?
Coordinate.
Yep, coordinates. One of the coordinates will do. So if you know one of the coordinates, you will be able to find plus c. Is that right?
Yes.
Thank you. So let's move on. Now, particular solution. If you're given a point xy that lies on the curve, then we can make a substitution to determine the numerical value of c. And this is called the particular solution of a differential equation. Alright? You no longer a family of solution. You have one particular solution. Alright? So let's try this. Find the antiderivatives of the following functions using the given points to find the particular solution. So we know that dy dx equals to 3x cubed plus x minus 2. So therefore y equals to 3x to the power of 4 divided by 4 plus x squared divided by 2 minus 2x plus c. Now we can substitute. 9 is therefore 3 times 2 to the power of 4 divided by 4 plus 2 to the power of 2 minus 2 times 2 plus c. Alright, so 9 equals to 10 minus c, therefore c equals to 1. Alright? Pretty straightforward. Now write out the equation. Y is therefore 3x to the power of 4 divided by 4 plus x squared over 2 minus 2x plus 1. Alright, I'll give you 2 to 3 minutes to work on part B. By the way, that's a cobbler, alright? One more step, you need to write out the equation, function. You got it. You must always write out the function because it wants the particular solution. The function is important. Once you find C, you must always write out the function. Alright, I'm going to reveal my answer now. So, what I've done is, I make life a little bit easier for myself. I wrote this as 2x to the power of minus 3 and x to the power of minus half. And therefore, I can actually find fx. First derivative of fx, and then I can find the function, plus c. So substitute minus 1 over 16 and 4 into the function, and therefore c equals to minus 4. And we always write out the function. Says here, find a particular solution. That is important. Always write the function. Alright? Now, example 2. Determine the equation given this. So first, again, you need to work out the antiderivative and then the function. Right? So I'll give you time to do it. Alright, revealing my answer. I've got c as minus half. So therefore y equals to minus 1 over x plus x squared over 2 minus half. Alright? So second example, you know what to do now, you know how to determine the equation of y. So finally, example 3. A quadratic function gx has the gradient function of 3x minus b. Given that the gradient function, when it is when x is 4, the g dash 2 is 1. G dash 2 equals to 4, and given that the function when x is 2, the function yields 11. So you need to determine the value of g1. Now, the first thing you need to do is actually work out what b is. From b, you need to work out the equation, and then from the equation, you need to determine the value of g1. So there are 3 steps altogether, right? So you know that that equals to 4. So therefore, 4 equals 3 times 2 minus b, and b is therefore equals to 2. So you know the gradient function is 3x minus 2. Alright? Can you continue with the rest, please? you can give your answer in improper fraction. I've given you that. Got it? Most of you got it? Let me review my answer now. Alright, so I got Q1 is 17 over 2 or 8.5. It doesn't really matter whether you give it to me in a fraction or give it to me in a decimal. It's no issue at all. Alright, so I think that's the end of the lesson. You've got enough exercises to do from Sadler. And I'm going to stop here.